Okay, order of operations. So most of us have seen the concept, and we kind of touched on it last class, where we have parentheses, any kind of grouping, and even braces. You could even include braces here. So all these things could group things up. If there are things to be done within parentheses, we would do those first. If there were operations to work out addition, subtraction, multiplication, division, within parentheses, we would do those first. Now, if we go one step at a time through this process, we can check in our problem right here to see if there are any parentheses, groupings, that we can do first. Clearly there are not, so let's go ahead and add the next step in our understanding of order of operations, exponents. So anything such like this, or any number to some exponent, power, we would go and address that next. Let's go to our problem over here and see if there's anything that looks like an exponent that needs to be addressed. Clearly there is not, so we won't do anything in that particular category, but if there was, that would be coming next in our order of operations. The next thing, multiplication, division. Now, a lot of times when we think of multiplication and division, we think that multiplication has to come first or division has to come second. That's not necessarily true. So when we multiply or divide, there is something that's very important to note, and that is always when you see multiplication and division, we will always work left to right. Now that's in the event that you see lots of multiplication and division side by side. Let's take a look at our problem here. Do we have multiplication or division? Yes, we do. So I'm going to just go ahead and write this problem so that we have a reference. And you can see in this problem we have multiplication, but just one. So therefore, we'll do that first. Positive 6 times a positive 2 is a positive 12. So what we've done is we've taken care of the multiplication and or division, but in this case, just multiplication in our problem. With that said, we can move on to the final step, which is addition or subtraction. So in our final step, we would look for any kind of adding or subtracting that we can do within our problem. And so looking at our problem over here, if we were to have lots of addition and subtraction lined up, we would simply work it left to right. Hence why I have this very important note of left to right encompassing multiplication, division, addition, subtraction. Now if that doesn't make sense to you, I don't expect it to, you will see it come up later in a problem. In our problem here, it's pretty straightforward. 48 plus 12, that's a single problem that we need to take care of, and so therefore our answer is 60. That's it. Any questions about your number one? Want me to do yours? So just in this problem, we've reviewed all the different components to the order of operations that can help us solve them methodically and not get hung up. Let's do some more. All right. This is a great problem. Let's talk about why. First, let's check. Do we have any P parentheses, brackets, braces, absolute values, any kind of grouping that we need to address? No, there isn't. So we'll move on to the next step. Any exponents, anything you see to a power? No, not in my problem. Next thing, any multiplication and division? Yes, there is. Now, which do we do first? Do we do the multiplication first just because verbally we always state it as multiplication and division, and naturally by the way it's stated, we always do the multiplication first? No, we don't. left to right. So if you're looking at this problem, if you only just go, okay, parentheses, exponents, multiplication, division, addition, subtraction, you will make the mistake of doing 3 times 4 first because it's multiplication. Multiplication supposedly has to always come before division, which is wrong. In the event that you have them side by side, you need to work left to right. So this is where that left to right principle comes in, and it's not always multiplication before division, it's whatever comes first, left to right. So 21 divided by 3 comes first when reading this multiplication and division left to right, so therefore that's what we do first, then we do the multiplication. And then of course now 7 times 4, 28. This again reinforces that multiplication, times tables, products, those are all important for you to know. Any questions? All right, let's go to number 3. Now, in contrast to the previous problem, I've got 6 times 4 divided by 2. Notice how in this problem, I've got the multiplication before the division. Now, do we do the multiplication first just because we read it first through here? No, we don't just do the multiplication first because we say parentheses, exponents, multiplication, division, addition, subtraction blindly. We do the multiplication first here because it comes first when reading this left to right. Because I've got multiplication attached to division, or vice versa, division attached to multiplication, we have to work it left to right. So 6 times 4, 24, then the division, 24 divided by 2 is 12. Questions? All right, good. Next. All right. In this problem, we need to again start out at the top. Just get in the habit of starting at the top, and by the time we get to the ones that actually have parentheses or groupings that we have to take care of, it'll be second nature to look for those. So, do we have any groupings? Parentheses, brackets, braces, absolute values that can be taken care of? No, there is not. Exponents? Nothing. Multiplication and or division? Yes, we have multiplication right in the middle. So that would get taken care of first. Now we don't have side-by-side stuff like we had here, but in the event that we did, we'd work that left to right. So we ignore 14, we ignore plus 4, and we just focus on the negative 2 times 2. Try to include the sign so that you do the whole thing, and you make sure it's not just 4 that gets written down, but whatever the sign that comes with the 4, negative 2 times a positive 2 is a negative 4. And again, if you had done your previous night's homework, working with your signs and times tables and all of that, this should be no problem here. Okay, do we have any division? Any other multiplication? No. Let's move forward. Addition and subtraction. Now, again, if you're just blindly following this and going through it verbally, PEMDAS, you're going to make a mistake. The mistake you're going to make is to put these two together because you're blindly adding because it says A then S. That's not true. Just like multiplication and division, if you have addition next to subtraction or subtraction next to addition tied together, you need to work left to right. Remember that. Question?
Is that negative or is that 14 minus 2 times 2?
It is. It's this. You can look at it the same way. It is 14 minus 2 times 2, but it doesn't change the fact that when you go do the multiplication, you got to take into account the sign, right? So it is 14 minus 2, but what takes precedent? Negative 2 times 2. So I think the other question that you're asking is there a difference between 14 minus 2 and 14 negative 2? Well, negative 2 placed after 14 is subtraction. Now, if they put a parentheses here, then we're multiplying them. Or if they straight up, like, really carefully put a dot there, which is not going to be seen, you would know they're multiplied. However, in this case that you're asking about, it is 14 minus 2 times 2 plus 4. But we know that multiplication precedes any kind of subtraction, so we multiply these, and when you multiply, we include the sign with it. Okay, did that answer your question?
Yeah, it did.
Great. So now, we're not going to add these two, we're going to subtract first, because left to right addition subtraction. So 14 minus 4 is 10, and then I'll bring down this plus 4, leaving me with one final step, 10 plus 4, 14. Any questions about that problem? All right, let's go on to 5. All right, things getting a little bit more complex. As things get more complex, what I recommend that you do is take the time to make sure that you write your problem down correctly. It's very easy to write a problem down incorrectly, go through all the work, do a great job, and then at the very end realize that you just made an error with your sign. Maybe it's that you copied part of my problem, or you copied my problem altogether. You did all the right work, but your problem is wrong just because you wrote things down incorrectly. Okay, here we go. Parentheses. Any groupings, things inside groupings that can be addressed? No. So we haven't seen that happen yet in any of our prior problems, including this one. But something new is that we now finally have exponents that we can work with. Let's go take a look at these exponents. So I've got this 5 squared and this 3 squared. So in my problem, I have 2 exponents that can be addressed. Let's take a look. 5 squared, 25. You have to know your times tables or it's going to be tough. Minus 18 divided by, well, the next one. 3 squared is 9. Times 3 minus 8. So in my first line of work, I have addressed all the exponents in the problem. Are there any questions about what we've done? Okay. Next, let's move down, since all the exponents are done, to the multiplication and division. Let's take a look and go see if we can find some. Well, I can. I can see that I've got multiplication here, and I've got division here. Now, if I do these out of order, I will be wrong. If I do these blindly based on how I wrote the order of M then D here, I'm going to be wrong. I need to make sure that if I've got multiplication side by side with division, that I work left to right, no matter which one comes first. I have to work left to right, meaning that in my problem, the division comes first, and as was stated a moment ago, I have to include the sign. Remember to include this sign, otherwise you might make a mistake. So with that said, let's go work this out. 25, nothing happens. Negative 18 divided by positive 9 is negative 2. You have to know your times tables. If you don't know your times tables and aren't familiar with your signs, it's going to be a little bit of a struggle. All right, so negative 18 divided by 9, we did that because when you have division side by side with multiplication, or vice versa, you've got to work left to right. Now, what comes next? Well, I'm not done with multiplication and division because I still have this multiplication problem right here. It was always there, times 3 times 3 times 3. Whatever the result of this was has to get multiplied by 3. Now, it's a little bit tougher to see because all the numbers are spread out, but it's clear that this has to get multiplied by 3. So let's go ahead and work that out. 25, negative 2 times 3 is negative 6 minus 8. Now, if you don't like the way I'm writing this down because it makes it confusing because this giant gap here, then close up the gap. The reason why I leave these gaps here is to show you what everything becomes as we work things down. So you can see the progression of how this whole middle area turns into a negative 6, and then we're down to whatever's left over. Now, if you can see in this problem, I am completely finished with my multiplication and division, leaving me ready to complete the addition and subtraction. And so let's again refer back to our rules. With addition and subtraction, we don't blindly just add, we don't blindly just subtract, we work left to right. And if I do that, I'm just going to work left to right. These are two subtraction problems back to back. So I'm just going to work left to right. 25 minus 6 is 19, ready to subtract 8 from it in just a moment. Then my last subtraction problem, 19 minus 8 is 11. Questions about that at all? All right. Okay. Let's keep on rolling. Remember, it's really to your benefit to take your time writing down these problems correctly from the start. If you write them down incorrectly, it could end up being a lot of correct work on the wrong problem, which would be frustrating for you. All right, let's get going. Well, we see some parentheses. For the first time in all of our previous problems, out of our previous problems, we see parentheses. However, these parentheses aren't the type of parentheses that I'm really referring to. When I'm talking about parentheses in this first step of parentheses, it's actually stuff that inside the parentheses can be worked on. Now, from previous sections, you guys know that when I have just a number in parentheses, and not necessarily an operation, negative 3 plus 7 squared, something like that, right? This is what this refers to, actually having to do something in the parentheses. The reason why these parentheses are here is to make sure that there's not confusion with this negative value. If this is written as 6 minus 3 squared, this could be easily misinterpreted as to what we need to be doing. This is a different message from this. This is saying take negative 3, square it, and then multiply it by 6. This is saying take 3, square it, and subtract the result from 6. Very different. So the function of these parentheses is to ensure that they communicate to you, the problem solver, that they want you to square just the negative 3 and then do multiplication. So let's go do that. Negative 3 squared, negative 4 squared. We have duplicates of the same kind of idea in this problem. So what's negative 3 squared? Negative 3 times negative 3, which is a positive 9. And so that's going to be 6 times 9. What's this one? Negative 4 squared, negative 4 times negative 4, which is a positive 16, and that's going to get multiplied by a negative 4. So what I've just done there is, I've sort of taken care of the parentheses, but not in the sense that it's originally designed to kind of talk about. I've really actually just done the exponents. That's really what I've done. Okay, let's take a look at the next problem, multiplication and division. So I have multiplication here, there's 6 times 9, and I have another multiplication here, negative 4 times 16. So if you want to, you can recognize that there's no division, but I have two multiplication problems side by side. It doesn't really make a difference how you look at it. If you work it left to right, you should still get the right answer. So 6 times 9, once again, knowing your times tables is a benefit to you, is 54. And then the other one, a negative 4 times 16, is a negative 64. be sure not to make the mistake of forgetting to write down whatever sign comes out of this. A negative times a positive is a negative. A positive times a positive is a positive. Include your signs. Include your signs. So, if you have a good handle on your times tables, a good handle on how negatives and positives work, this shouldn't be too bad. All right, with that said, we're done with all the multiplication. There was no division. We can move forward to addition, subtraction. This looks like just a subtraction problem. 54 minus 64, negative 10. There it is. Questions about that at all? All right. Okay. Anybody want me to do theirs? Yes.
Can you have it line?
Yeah.
Okay, let's be honest. Like 7 and then be negative 3 squared minus 2 negative 6 squared.
Okay. Tell me your first line of work.
I did the negative 3 squared,
Good. What'd you get?
9,
Good.
and then negative 6 squared,
Which is?
36.
Okay. Tell me exactly how this reads left to right. Like I would say that 6 times 9 minus 4 times 16. Tell me left to right what this looks like.
It'd be 7 times 9
Good.
minus 2 times 36.
Exactly. Good. So notice how these two problems parallel each other. Now, what comes next?
Multiply.
Good. What are you going to multiply?
7 times 9.
Great. What did you get?
63.
Great. Good. How about the other one? What are we going to multiply?
2 and 36.
Positive or negative 2?
Negative 2.
There you go. Good. Always include the sign. What do you get there?
Negative 72.
Very good. So what I have here is 63 minus 72. Keep going. What's left?
You would subtract them.
Good. What do you get?
I haven't done that yet. Nine.
Positive or negative?
Negative.
Exactly. Why negative?
Because that's the higher side.
Exactly. Good. Other questions? Okay, let's go on to number 8. So number 8, finally we have a problem where we actually have something within the parentheses to work on. Write it down correctly and then let's get started. Okay, so unlike the previous 2 problems that we did, these parentheses function to group up an operation. The parentheses in this problem group something you need to do. And that something you need to do in these just happens to be subtraction for both. Let's take a look. So 3 minus 7, that's going to be negative 4 squared, minus 4 minus 10, which happens to be negative 6 squared. So what I have is a negative 4, 3 minus 7 is negative 4, 4 minus 10 is negative 6. I have both of those that just got worked. I did whatever is here in there. I took care of that. Now you may be asking the question, Andrew, why did you leave them in parentheses? Well, I left them in parentheses because I want to know exactly what needs to be squared. So notice how 3 minus 7 is negative 4. I know that negative 4, the entire negative 4, needs to be squared. Because negative 4 times another negative 4, when I now do the exponent step, is a positive 16. And then the other one, a negative 6 squared, because I'm doing the exponent step, is a negative 6 times another negative 6, which is positive 36. But stop for a moment. Where does this minus sign come from? It comes from above. Because originally the problem is minus, minus, minus. This negative sign does not come from here because negative 6 squared is a positive 36. But because I have this minus sign coming down with the problem, it now becomes negative. So that's actually a very tricky piece in that problem that you need to be careful with. Easy to make a mistake there. Make sure you know it. Okay? And then finally, 16 minus 36 is going to be a negative 20. Done. Questions about problem number 8? Anything? Anything? All right, I'm going to roll on to 9. Okay, I'm not sure I'm going to be able to fit this in here. Let's see if we can. All right, here we go. So, just like the previous problem, I am going to do the stuff in the parentheses first. 2 minus 4 is negative 2. And I'm just going to bring down everything else that has nothing associated with it but needs to be attached to it. Let's go do the other one. 1 minus 3 is also negative 2. Once again, I'm going to bring down everything that should be attached to it that I couldn't really work on. Are there any questions about that first step? Okay, let's go on to the next one. So in the next step, I've got all of my parentheses done, and so I can move on to exponents. My next step, exponents, means that I'm going to take the exponent part of each piece and address that. So a negative 2 to the third power is a negative 2 times a negative 2 times another negative 2. Now, as a side note here that I'll attach to exponents, as a side note, if I have some negative number to an odd power, it will always end up being negative. If I have some negative number to an even power, it will always end up being positive. So I know that any negative number to an odd power will always end up being something positive, and any negative number to an even power will always end up being positive. Did I mess that up? Negative to odd, negative, negative to even, positive. There you go, you got it. So I've got a negative number to an odd power. That means that it's going to end up being negative. So what is the negative? 2 times 2 times 2, which is 8. Again, your ability to work through times tables plays a very important role in your success. Let's go do the other one. Just so happens that in my problem, they end up being the same thing. Negative 2 to the third power, once again, obviously is a negative 8. I did the previous one correctly, so I can just copy it over. And so there it is. All right. Now, with that said, I'm done with my exponents and I can move on to multiplication and division. I've got a multiplication problem here and another multiplication problem right beside it. 9 times negative 8, negative 9 times negative 8. Let's do both. A positive 9 times a negative 8 is a negative 72. A negative 9 times a negative 8 is a positive 72. It's very important that you write down the signs for everybody, especially the positives. It's real easy to leave off the positive sign here and not pay attention to it, but that plays a very important role in connecting this one to this one. Negative 72, positive 72, and of course, a negative 72 plus a positive 72 is going to end up being 0. So that's the answer for my problem. Yes?
I have my problem.
Okay, let's do yours here. All right, go for it.
So it's 6 times 2 minus 4, and the 2 minus 4 is in parentheses,
Uh-huh.
to the third
Uh-huh.
power, minus 3 times 4 minus 6
Okay.
to the third power.
All right, let's get going. What happens first?
The parentheses,
Okay, let's do those. Go for it.
-2 on each.
Very good. Read to me, left to right, exactly what it should look like.
6 times -2 to the third power,
Great,
and then minus 3 times -2 to the third power.
great. Did you make sure to leave the negative 2's in parentheses?
Yes.
Fantastic, wonderful. So off to a good start. What do we do next?
The exponents.
Exactly. So we've got a negative 2 to the third and another negative 2 to the third. Tell me what they become.
-8.
Of course, yes. Good. Tell me, left to right, what it should look like.
6 times -8 minus 3 times -8.
Did you happen to leave the negative 8's in parentheses? Awesome. Good. Let's keep going. You're on the right track. So that's 2 steps that are looking good. What happens next?
Multiply
What are you going to multiply?
6 times -8.
Great. And what else?
And 3 times
3 or -3? Follow? So you got to be really careful. 9 or -9? Okay, so -3 times -8. With that said, tell me what each of them becomes.
So it's the first one is -48
Great.
minus probably 24.
Okay, so this is the mistake. You said minus positive 24. Now you could do it that way, and ultimately it would end up being negative 24, but if you look at it like it's the entire sign, -3 times -8 is
24.
just straight positive 24. So you're done there. Notice how what I did in my problem, -9 times -8 is positive 72. So that's a very common area where students can make a mistake, very normal, and that's why I try to drive home the point, include your signs when you multiply. All right? And then from there, I think you can get your answer. It should be a negative 24. All right? Most of it pretty good, just that one spot with a small error there. But of course, that small one makes a difference. We okay? Yeah? Okay. On to number 10. All right, so number 10. Probably squeeze this one right down here. Let's go do that over here. So I've got a bracket, then 2 times 6 minus 3 squared. I don't know if I'm going to squeeze it in. We'll see what happens. Probably run out of space. Whatever. Okay, so now there is a little item that I'll put a star here, and that star goes with inner and inner to outer. So when we're working parentheses, we need to always remember that it's inner to outer. What do I mean by that? Well, if you can look at this, I've got double groupings. I've got a grouping inside of another grouping. And in the event that you have a double grouping, one inside of another, you will work innermost to outer. So you wouldn't try to work anything with the 2 first. You would address the 6 minus 3 in your first step. So let's look at what that would look like. I'd leave the bracket alone. 6 minus 3 is 2. And I'm now done, oh, not 2, what am I doing? I'm now done, 3, with my innermost grouping. Now, I move out from there. 6 minus 3 was 3, 2 times that, so 2 times 3 would be 6. And that is the result. If you want to really be consistent about everything, doesn't have to be, but it's going to be, all that became 6. Everybody following me so far? Okay. And then one last step, do the exponents. So that's 6 squared, the whole thing squared, and so 6 squared is 36. Done. Okay. Any questions about number 10? Anything I can help you with? Great. All right. On to 11. All right, so in 11, I've got 2 times bracket 8 plus 9 times 6 minus 4, and close that bracket up. Okay, so this theme of doing the innermost is again stressed and practiced in this problem. A lot of students are going to make the following mistake. What mistake is that going to be? To add these. But by adding these, you violate the rule that when you have double groupings or more, that you must work the most inner grouping first and then outer. If you do 8 plus 9, you're working something outer to the inner, prior to the innermost. Take care of the innermost first. So that's what has to be taken care of, 6 minus 4, which is 2. There's your first one. Now, from here, it should hopefully be a little bit easier to see that if you're working order of operations properly, you still wouldn't add 8 plus 9. Because we know from our order of operations that addition comes after multiplication and division. And in my problem, I have 9 times 2, a positive 9 times a positive 2 first. Multiplication has to come before addition. And so positive 9 times a positive 2 is not just 18, but positive 18. Write the sign down, no matter of whether it's positive or negative, write it down, because that makes the picture easier to see of what you need to be doing. Are there any questions? Okay. Now, this one's not so bad. 8 plus 18 closes down the grouping. 8 plus 18 is 26, and I've got a 2 in front of it. And now, pretty much done. One final multiplication, 2 times 26, which is 52. Make sure you can get your number 11. Let me know if you have any questions. Anything? Small mistake? Good. You caught it. It's good. Better for you to catch it than me. That means you're your own critic. Everybody okay? Ready to go on to number 12? All right, let's roll. Okay, this one looks like it's got quite a bit associated with it, so let's see if we can take care of this problem. Here we go. So I've got 12 plus 3 2 times the quantity 2 cubed minus 4 divided by 18. A lot of stuff going on in this problem, but if you follow the procedure that we've done all the way up to this point, built up to from our simplest problems to now a little bit more complex, it should be okay. Inner to outer, that's what should be going through your mind, inner to outer. What is the innermost? This is the innermost, parentheses, grouping. And so within there, we actually have two different things going on, a subtraction and an exponent. Well, we know from all of our experience so far that subtraction comes well after any kind of exponents. So I would address the exponent first. And so in my next line of work, I have 12 plus 3, 2 to the third power is 8 minus 4. And so that is what I would do next. And I still have a little bit of work to do there. So if I were to be very precise about what I needed to be doing in my first step, it is simply that I'm doing the exponent in the innermost parentheses there. That's what I just did. But now I still have to address closing down and finishing out the operations within the innermost parentheses. And so let's go do that. 12 plus 3 times what's 8 minus 4? 4. And now that innermost parentheses is done. Ready to move outward from there, but very carefully. Do I add these first? No, because this is multiplication. And we know, again, that multiplication comes before any kind of addition. A lot of students will make the mistake, add these together. Don't be that student that does that. Recognize that multiplication is here. So there it is. Positive 3 times 4 is a positive 12. Now, again, I want to stress, write the sign down. So positive 3 times positive 4 is positive 12. Write it down, write it down. Okay, so easy to miss that. Write it down. All right. And now I can add these. 12 plus 12 is 24 divided by 18. I'm going to get a fraction for this answer? Maybe? We'll see what happens. So in this problem, this looks like a fraction. I'm going to throw out a little note here. I hope I didn't make a mistake. I don't think I did, but I could have. A divided by B is the same as A over B. So this is another side note. A divided by B is the same as A over B. Why do I say that? A divided by B is the same as A over B. And the reason why I do that is because it doesn't look like it's going to be a clean division. I need to reduce that. So how am I going to reduce this? Well, if I divide everything by 3, I'm going to get 8. Oh, did I make a mistake? 3, 8 over 6. I could have divided by more. What am I missing? 8. No? 6. Divide by 6. Not paying attention. If I divide everything by 6, I'll get 4 over 3. Now, if you divided by 3, you could do that, but you would have had to keep dividing. So now what I'd like to do is, I am almost certain that there is somebody over here, and I'm going to type this answer in just to make sure I got it correct. There's somebody here that probably has a problem that got stuck here. Let me know. I'll help you with your fraction because we really haven't reviewed too many fractions yet. Is there anybody that got to the fraction step and couldn't reduce it and get down to their correct answer? Let me know and I'll help you reduce your fraction. Okay, let me know. Please let me know. Okay, well, I'm gonna wait for 1 or 2 minutes so people can finish their problems. And if you got a question, let me know. Anything? lot going on in this section, a lot. Okay, let's move on to number 13. Are there any questions on number 12 before we go? All right, 13. This is actually easier than anything that you've done before. Now, it looks a little bit tougher because, of course, it's two things going on at the same time, but think about them individually. 14 plus 7, if I just gave you that as its own problem, you would tell me, oh, geez, that's easy, Andrew, 21. And you'd be right. And if I gave you just the 4 squared minus 3 squared, if I just gave you 4 squared minus 3 squared as any of these previous problems, you would say, well, Andrew, that's not bad at all. That'd be 16 minus 9. 4 squared is 16. 3 squared is 9 subtracted. With me so far? And then you would probably clean this one up to be 16 minus 9, which is 7. Again, if I gave you just 4 squared minus 3 squared, you would get it to 16 minus 9, which becomes 7, and you'd be done. But the only extra bit here is that you got to do 21 divided by 7, which is 3. No big deal, and that's all there is to it. So, as you finish your problem, let me recap the complexity of this problem. The only thing that makes this difficult is it's essentially 2 problems in one that then have to be brought together at the very end. That's it. So as long as you follow your order of operations for the numerator by itself, the denominator by itself, and then at the very end, look at how you can simplify them, you're going to be just fine. Yes?
On the other question, where'd you get the divided by 6 when you put it into the fraction right there?
So this is from our previous study, greatest common factor. What is the biggest number that both of these are divisible by? 2 is divisible by them, or they're divisible by 2, they're divisible by 3, but even better, they're divisible both by 6. So from our last class, recall we did that greatest common factor, GCF, and I knew by testing numbers that I could divide both 24 and 18 by 6, and that's what the result is. So refer back to the GCF notes from the previous section. Other questions? All right, 14, here we go. Again, you want to work these as if they are their individual problems on the top, numerator, and bottom, denominator. If you think about them that way, it's not so bad. In fact, the problems themselves are significantly easier. The individual numerator and the individual denominator are easier than what we've done prior to these. So, work the problems individually by top and bottom, and then at the very end, tie them together. With that said, let's take a look at mine. If I look at my problem in the top, the first thing I would need to do is positive 6 divided by negative 2. Positive 6 divided by negative 2 is going to be a negative 3. Take a look at that. If I just was working this problem right here, I would have a positive 6 divided by a negative 2. A positive divided by a negative is a negative. 6 divided by 2 is 3. So that's it. In the denominator, if I were to be working it by itself, well, 2 squared is just 4. So there it is, almost done. Again, if you look at these like they're just individual problems, top problem, bottom problem, they're really not that bad. And then finally, what's 7 minus 3 here? Well, 7 minus 3 is 4. The 4 down here was already complete, so it gets left alone. And now I'm ready to do one final step of tying the top and bottom together. So essentially, what did I do? I worked out the top, worked out the top, worked out the top, worked out the bottom, nothing else left to do. And now I can bring them together into one final piece of simplifying. 4 divided by 4 is 1. Any questions at all? Let's look at this next one. If you look at this one, it's again, individually, just the top, just the bottom. Look at them separately. They're nothing compared to the difficult stuff we've done before. Nothing compared to that. There's another way that you can do these. You can literally disassemble them. Just take the top and do it off to the side. Just take the bottom, do it off to the side, and put them back together. It's really up to you. I'm not going to do it that way, but I just want to throw out an option of how to do it off to the side. So with that said, I'm going to do the top. 4 times negative 4 would be the first thing that I would do. And so I've got a positive times a negative, which is going to be a negative 16. What else do I have? I have a negative 6 times negative 4. Recall earlier the question was asked, got to be really careful here, negative 6 times negative 4, and include the positive sign on positive 24, because negative 6 times negative 4 is a positive 24. Be very careful about that, and always multiply with your signs. Finally, the denominator, 8 minus 5, that's an easy one, 3. So notice how by just working the numerator, top, separate from the denominator, and you look at it, again, nothing compared to this, what we did earlier. We still have a little bit of work to do in the numerator because negative 16 plus 24 needs to get worked on, and negative 16 plus 24 is a positive 8. If you didn't remember that, if the signs are different, you subtract them and take the sign of the bigger number. The denominator was already done. That's a 3. So now at this stage, I have done everything in the top. I work the top, I work the top, I work the top. I've done everything in the bottom. I've worked the bottom, I've worked the bottom, nothing else left to do. And now, just like the previous 2 problems, I can look at the top in relation to the bottom and see if I need to simplify anything. 8 and 3, do they have a greatest common factor? Something that they're both divisible by? The answer is no. I can't divide 8 and 3 by anything that's going to make them smaller, so I'm done there. Questions at all? Anything I can help you with? Anything? No. Sixteen is going to be our last problem. You don't have to worry about 17. I won't throw anything like that at you. 17's not really necessary to get too far into. Let's see here. Let's just clear out this entire area here. All right, last problem of the day. Here we go. So I've got negative 2 squared plus 3 times 20 divided by 2 minus 6, and that's it. Make sure to write down the problem correctly, write it correctly, so we minimize the chances of any kind of error. Okay. I want to make one very important note here, and that ties to this one. If I have a negative number outside of any exponent, no matter what, this is always going to end up being negative. However, if I have, and instead of using that letter A, let me use the letter N to be consistent. However, if I have a negative number inside of parentheses to an exponent, then my rules down at the bottom here apply. Odd, even. Pay attention one more time. Look at this one right here versus this. These are two different things. When the negative sign is outside of parentheses like this, you're always going to be negative. If it's inside, then look at the power. Is the power odd or even, and follow that. Okay? This is tricky. So this one should be a negative 4. Period. It's a negative 4. Because when it's outside, the way you look at it is you just square it or do whatever your power is and then make it negative. When it's inside like this, you've got to follow your odd even power rule and then decide negative or positive. It's tricky. It's really tricky. So there it is. I wanted to point that out. So we take care of that, and then we need to go work out all this other stuff. So let's go take care of that business. Okay, so what do we have here? I've got a parentheses, innermost parentheses. 2 minus 6 needs to come next. And so, or with it, 2 minus 6 is a negative 4. And then I have a 20 divided by that. Go do your first step. Make sure your first step is worked out, because this is your last problem of the day. Everybody got their first step, hopefully? Okay, let's keep going. What happens next? Keep on working from the inside out. From the inside out. I did the inside out. 20 divided by negative 4 is going to be negative 5. And then I'm going to bring everything else down. Negative 4 plus 3. So notice we used to have just this as one of our problems. Just like this, sort of. Inside, out. 2 minus 6 is negative 4. Then I can do this. 20 divided by negative 4 is negative 5. Now what comes next? This, adding, subtracting, or multiplying? Multiplying. So I need to take care of this next. So I've got a negative 4, positive 3 times negative 5 is a negative 15. Make sure your signs get laid down properly. Positive 3 times negative 5 is negative 15. And then I'm almost done. Negative 4 minus 15 more is negative 19. Done. Make sure you can get that. If you can't, let me know. We can do your problem. Get another practice one in. Hopefully you got it right though. If not, let me know. Questions? At all? Anything I can help you with? That's pretty comprehensive order of operations. We did just about everything there. Anything I can do for you?